First thing we always have to do is factor this guy, so it's going to be 3 times x plus 2 over x plus 4 times x minus 2. Look to see if any of the factors cancel. If they do, that's a whole, but nothing's canceling, so there are no wholes. So then everything that makes the bottom 0 is going to be a vertical asymptote. So we have vertical asymptotes at -4 and +2. To get the horizontal, you look back at the original, take a look at the highest powers. Since the power on the bottom is bigger, it's just going to be y equals 0. Then I like to check to see if it ever crosses that asymptote. So check to see if this 3x plus 6 over x squared plus 2x minus 8 ever equals 0. And so you just solve ever equals whatever you got for the horizontal asymptote, which in this case was 0. So just solve this like normal, and oh no, right? Like if you multiply both sides by the bottom, you'll just get, it'll happen where the top equals 0. So it'll happen when 3x equals -6. So it will cross when x is -2. So we'll get to that when we graph, but it's good to know. An x-intercept, no matter what graph you are graphing, an x-intercept always happens when the y is 0. So if you want to know when the y is 0, if 0 equals this, you can multiply both sides of the equation by the denominator, and then it'll basically go away because 0 times the denominator will be 0. So it's basically where the top equals 0. So you have a 3x plus 6 equals 0. So it ends up being the same thing we just found, because our horizontal ended up being 0 anyway. So we have x equals -2, and that's our x-intercept. And our y-intercept is always where the x equals 0. So if the x is 0, the y is going to be 3 times 0 plus 6 over 0 plus 0 minus 8 is 6 over -8 is 3 over -4. And so now we plot what we've got. So I've got vertical asymptotes at -4 and at 2. I've got a horizontal at 0. I know it crosses this horizontal at -2, which happens to be also my x-intercept. And I know that the y-intercept is -3/4. So somewhere there. And now we can just start graphing these things. I know that because this is the only place it crosses this axis, I can start my graph by knowing that I have to be down here over on this side for sure, because I can't come back to cross it over here. So I have to be going down and hugging that x-axis on that side. Also I know because this x-intercept came from an odd-powered factor, that it's not going to bounce back down, that it's going to cut on straight through, just like it did with polynomials. These aren't their own beasts. They have the same same properties we had before. So remember, it was odd powers cross and even powers touch or bounce. Same thing happens here. The x plus 2, so the x equals -2 came from an odd power, so it's going to cut through there. And the same thing works for the asymptotes. Since these asymptotes came from odd powers, it's going to change signs over the asymptote. It's going to cross. So looking at this asymptote, since it's up on this side, it'll be down on this side, and which puts it snugly down here. I know I never cross this again, and I know eventually I have to reach my horizontal, so I'm down there. And on the other side, by the same reasoning, this asymptote came from an odd power, so if I'm down here, then I'll be up there on that side, and I'm not going to cross this again, so I'm just going to come down and get close to it over there. And there's my graph.